Have you ever gazed up at the night sky and wondered about the stars? These twinkling lights are more than just beautiful points in the sky. They are living entities with their own life cycles, stories, and destinies. Every star begins its journey in a stellar nursery, a vast cloud of gas and dust known as a nebula. But what transforms a simple cloud of cosmic dust into a radiant star? It all starts with gravity. Over time, gravity pulls the gas and dust together, forming clumps. As these clumps grow, their gravity strengthens, attracting even more material. This process continues until the core becomes dense and hot enough to trigger nuclear fusion. This marks the birth of a star. In the core, hydrogen atoms fuse to form helium, releasing tremendous amounts of energy. This energy radiates outward, balancing the force of gravity, pulling everything inward. But not all stars are created equal. Their mass determines their entire life cycle. Let's start with the most common type, the average-sized star, like our Sun. An average star, once formed, enters the longest phase of its life known as the main sequence. During this time, the star fuses hydrogen into helium in its core, a process that can last for billions of years. But what happens when the hydrogen runs out? For a star like our Sun, the core contracts and heats up, causing the outer layers to expand. The star transforms into a red giant. As a red giant, the star starts to fuse helium into heavier elements like carbon and oxygen. This phase is relatively short-lived compared to the main sequence. Eventually, the outer layers are ejected into space, creating a beautiful planetary nebula. What remains is the hot core, which cools and shrinks into a white dwarf. A white dwarf no longer undergoes fusion. It will gradually cool and fade over billions of years, becoming a cold, dark black dwarf. But what about stars much larger than our Sun? Massive stars live fast and die young. These stars burn through their nuclear fuel much more quickly. When they run out of hydrogen, they expand into supergiants and start fusing heavier elements in a series of complex reactions. The core of a massive star eventually fills with iron. Since iron fusion consumes more energy than it releases, the core collapses under gravity, leading to a catastrophic explosion known as a supernova. A supernova is one of the most powerful events in the universe. It outshines entire galaxies for a short period and disperses heavy elements into space, enriching the interstellar medium for future star formation. What remains after the supernova depends on the initial mass of the star. If the star was moderately massive, it leaves behind a neutron star, an incredibly dense remnant. But if the star was truly colossal, it collapses into a black hole, a point in space with gravity so strong that not even light can escape. Neutron stars are fascinating objects, often spinning rapidly and emitting beams of radiation as pulsars. Black holes, on the other hand, are mysterious regions of space-time that challenge our understanding of physics. The death of one star often leads to the birth of another. The elements scattered by supernovae enrich the interstellar medium, providing the building blocks for new stars, planets, and possibly even life. The life cycle of stars is a testament to the dynamic and ever-changing nature of the cosmos. Each star's journey from a cloud of gas and dust to its ultimate fate is a story of creation, transformation, and renewal. So next time you look up at the night sky, remember that every star has a story, a life cycle that spans millions or even billions of years. Each twinkling light is a chapter in the grand cosmic odyssey. Thank you for joining us on this stellar journey. Don't forget to like, subscribe, and hit the notification bell for more cosmic insights. Until next time, keep exploring the universe with Cosmic Odyssey.